Greetings and hello. This is Professor Jeremy Caradonna from the University of Victoria, who's speaking to you today from afar. I will try to speak as slowly as possible, since I know not everyone is a native English speaker. It's my pleasure to be presenting to you today about my experiences in the Global South, and in particular in Peru, in high Amazon, Peru. 2 years ago, I was able to bring some students down to a wonderful research center in the high Amazon called the Sachamama Center for Biocultural Regeneration, where they study indigenous agricultural practices and both ancient and modern forms of what is called Terra Preta, and that's going to be the subject of my talk today. Not only Terra Preta as it exists in the Global South, in Peru, but also its potential applications in the Global North, which I think will be of interest to many people involved in permaculture. Terra Preta is a very special kind of soil that uses biochar, and what you're looking at here in the first slide is a small garden plot that is on the property of the Sachamama Center, and you can see the contrast between the two different kinds of soil. On the right, in the pathway, is the native soils that exist in South America that are called oxisols, Oxisol, that are rich in iron but are very poor in carbon and are difficult to farm in. And on the left, you see different beds or plots with a much darker color, and those are the Terra Preta beds that use biochar. So the objectives for this presentation are as follows. First, to discuss my experiences at the Sachamama Center in Lamas, Peru, and you can see the insignia there at the bottom right with a link to the website if listeners are interested in learning more about the Sachamama Center. Second, to discuss biochar, define biochar, and also to define and discuss Terra Preta, both as it existed in antiquity, and then to discuss how it's being made today in a more modernized form, which has been pioneered by the researchers at the Sachamama Center, and in particular a woman named Frederique Apfel-Marglin. We'll also be discussing MAMA, or Microorganismos del Monte, a Spanish term for the fungal-laden, fungi-covered leaves that are harvested from the tropical forest and which are fermented in a very complicated process and which are added to the Terra Preta. That's one of the interesting things about this modern form of Terra Preta, is that it attempts to replicate ancient processes which we're pretty sure involved fermenting a fermented brew, which activates the soil by getting beneficial bacteria and fungi into the soil. Finally, we'll discuss some of the potential applications of biochar and Terra Preta in the Global North, because of course the soils in Peru are quite different from what we find in places such as Canada, where I live. So to orient ourselves geographically and to get a better sense of what the actual problem is that Terra Preta is attempting to solve, and biochar as well, we need to look at a map here of Peru and of Amazonia in general. I think it's probably not news to many people listening, but there is a very bad problem with deforestation in Amazonia. And of course, Amazonia extends into the highlands of Peru and Ecuador and Colombia. We tend to think of the Amazon basin, the lowlands, but the Amazon extends way up into the hills, into hundreds and even into a few thousand meters. So that's where we are. We're in the Sachamama Center where we visited and studied is in a province called, or a department rather, called San Martin at the very western edge of Amazonia. And this department is probably the second worst or second most deforested department in all of Peru. It has a very, very bad deforestation problem, as do other parts of Amazonia. The style of agriculture that is used there, both by many indigenous groups and also by mestizos, is what is called slash and burn, or swidden agriculture. What's interesting is that once upon a time, historians believed that slash and burn agriculture went back thousands and thousands of years, and that it was once practiced very sustainably. Well, the new thinking on this is that slash and burn is in fact not a very old practice, but really only came about with the arrival of the Spanish and their metal axes, which created the possibility for cutting down trees at a much greater rate. The Spanish not only brought with them axes, but they also brought disease and absolutely decimated the indigenous population, both through disease and through warfare. And when the indigenous population were decimated, there was also a tremendous loss of cultural knowledge about Terra Preta. Terra Preta goes back thousands of years. We now know that the earliest Terra Preta that has been discovered is at least 9,000 years old, and it could be even older than that. So Terra Preta was practiced for a lot longer than the Spanish have been around, and a lot longer than slash and burn has existed. But a lot of that knowledge was lost over the last few hundred years, and slash and burn has become the main form of agricultural production. It's also called swidden agriculture. And what that means is that trees are cut down and burned, and by burning that carbon-rich material, you release nutrients, which then fall to the soil, and farmers will plant things like corn and beans directly into that ash. Now, the ash is very nutrient-rich, but of course it is not a very sustainable form of agriculture. The nutrients are exhausted within 2 to 3 years, sometimes even in the course of 1 year. And then the farmer has to move on to the next plot of land, which is cut down and burned. So this has happened over and over and over again for the last several hundred years, and the result is very bad deforestation. So what the Sachamama Center and other groups and researchers, especially some of the indigenous groups who are known as the Quichua Lamistas, which is a specific group within the broader Quechuan-speaking peoples who are working with the Sachamama Center, what they're trying to do is revive this ancient practice of Terra Preta, of making sustainable soils, as an alternative to deforestation. So rather than cutting down the forest and then moving on, you actually build your soils and you remain farming in the same place year after year, which is what ancient Amazonians were doing for thousands and thousands of years. This is another map to orient ourselves. That is the Department of San Martin, and the Sachamama Center is located in the town of Lamas, which is at the edge of the Amazon watershed in the high Amazon, and it's located at 800 meters, so it's fairly high up. The indigenous people who live in and around the town, as I said, are called the Quichua Lamistas, and there are perhaps 22,500 of them who live in small communities right at the edge of town and in little satellite communities around the town. And they speak Quechua or Quichua as their native language. Many of them speak Spanish as a second language. And they have really spearheaded the efforts to revive Terra Preta. As I said, the ancient cultural knowledge has been lost, but it is in the process of being rediscovered through the help of organizations such as the Sachamama Center. And there is a recognition amongst the indigenous population that slash and burn is unsustainable and that there needs to be a new, more sustainable form of agriculture that is consistent with the culture and history of the area. This is a photograph of myself and Dr. Frederic Appel-Marglin at the highest point in Lamas looking out across the valley. And if you look very closely at this photograph, you'll see fires off in the distance and big plumes of smoke that fill the valleys completely with smoke. And that is a slash and burn operation that is actively running. They're burning the forest right there. And just want to give you a sense of what the town of Lamas looks like and the urgency of this problem. Dr. Apfel Marglin has been at the Sachamama Center for 20 years, and she said that this was one of the biggest slash and burn fires she had seen in her 20 years in the area. When I'm giving this lecture in person, I often ask viewers to tell me what they're looking at here. And everyone raises their hand and says, a jungle. We're looking at a jungle. And in a sense, we are looking at a jungle, but we're actually looking at a man-made jungle. All of the plants that are in this photograph were planted by an indigenous community just outside of Lamas using sustainable Terra Preta soils. Now, from the point of view of an outsider, from someone who is not accustomed to living and working in Amazonia, it's very difficult to tell the difference between a jungle that happened to grow naturally and what we might call a polycultural agroforestry system that was created by human beings. And in a sense, this has been the problem with Amazonia ever since Europeans came to the area. When they first came to the Amazon, the Spanish thought that they were looking at jungle, but in many cases they were looking at orchards or farms, agroforestry operations that were created by human beings. So this is the same photograph, but it shows some of the plants that are growing in this picture. You have here banana, coffee, cacao, peach palm. You've got plants in the Fabaceae family, and of course, as permaculturalists, you know that the Fabaceae family is the legume family, which is the nitrogen-fixing family. So you have nitrogen-fixing plants that have been introduced into this system. You also have coconut, sugarcane, yucca, papaya, and so on. Some of those plants are native to Amazonia, and others, such as coffee, are not native. But what you have here is a good example of a dense polycultural and agro-silvicultural system in Amazonia. And this is the alternative to slash and burn, is to generating soils that are nutrient rich and do not require slash and burn, and which are based not on fast-growing annuals or even biannuals like corn, but rather on tree-based crops. So here you begin to have, I think, for the permaculturalists in the room, a beginning of an understanding of how this system might overlap with permaculture, which often emphasizes the growing of perennials, and especially of tree-based crops. And Amazonia has many different tree-based fruits and vegetables and other trees that produce nuts that are used for oil. In fact, there's well over 100 tree plants that are used in Amazonia. So in theory, this can be a very sustainable system, and I think that there is a lot for permaculturalists to learn from this system, both in the tropics and also in the global north. So now we start to get to the heart of the matter, which is an understanding of Terra Preta. What is Terra Preta? It means dark earth. It's also called Amazonian dark earths, or ADE. And it goes by a couple of different names, whether or not you're in a Spanish-speaking country or whether or not you're in Brazil. There's different names in Portuguese, etc. But it all refers to the same thing, which is a man-made soil, or an anthrosol, as opposed to a naturally occurring soil. This is a soil that is made by people, although interestingly it reproduces itself. In any case, it is a carbon-rich and highly fertile anthrosol with a long history in Amazonia. And the reason that it is carbon-rich is that the natural soils in Amazonia are naturally poor in carbon, in soil organic matter. They are highly weathered, they're often very wet, they hold a lot of water, and they tend to be much higher in clay content. And they're also rich in iron. Some plants grow very well in those kind of soils, of course, but a lot of plants that produce food want more carbon-rich, more nutrient-rich soils. And so ancient Amazonians began to make their own soils to produce more fertility. Terra Preta has been made with a variety of ingredients, both in antiquity and today. There is not one set formula or recipe. It is made differently from one place to the next based on what the available ingredients are. Also, in antiquity, it's still a bit unclear as to how it was made. It's hard to know what Amazonians were doing thousands of years ago, but there is a fair bit of evidence to suggest that fermentation, the fermenting of microorganisms was essential to the process, and also clay shards of clay are found in Terra Preta soils all over the place. And there's a lot of speculation and argumentation about what these clay shards were doing. One of the theories is that they were there to help retain water and also to aerate the soil. Another theory is that they were part of Amazonian spirituality, and even to this day, the Quichua will break clay bowls and pots as part of offerings to the soil. And of course, the soil back then and today has always had a very important spiritual component. So that's a bit of an understanding, though, of why that clay exists. The Terra Preta that is made today at the Sachamama Center for Biocultural Regeneration is a regenerated form that attempts to revive and approximate the Terra Preta of old, but it does so in a modernized form using sustainable local materials. So the mixture, the components of the Terra Preta soil that we made and that has been made at the Sachamama Center and in indigenous communities around Lamas is composed often of the following ingredients. Cow manure makes up about a third of Terra Preta, and it's important to note that this is very much a modern practice. Ancient Amazonians did not keep livestock. They did not have cows, and therefore they did not use cow manure. However, there is quite a bit of evidence to suggest that they were using human manure or humanure as part of the mix of ingredients that went into their ancient Terra Preta. We also used sugarcane residue as a kind of mulch for its carbon content, so that was another third or so of the recipe. Then we used what are called sacha inchi nuts. These are, in fact, we're using the husks of the nuts, not the nuts themselves, but the shells of the nuts, which were used to aerate the soil and to retain water. The fourth ingredient was biochar, and I have not yet given a definition of biochar, and I will in just a moment, but biochar made up a smaller percentage, but perhaps 10 to 15% of the recipe. And then finally, the last ingredient was compost, which was composted on site at the Sachamama Center and was made mainly from kitchen scraps. Beyond those ingredients, the last thing to add in is a bit of water and then the fermented brew of microorganisms, which I'll be explaining in just a moment. So before I explain how we made the Terra Preta and the biochar, this is just an example of what the finished product looks like. And what's interesting about the Terra Preta, well, many things are interesting, but one of the things is how high the carbon content is. The carbon content can be as high as 15% or even higher and this is in comparison to the very low carbon content of the natural oxasols, which you see surrounding this bed. That's incredibly high carbon levels, even too high, some might argue. When I look at the agricultural scene here in Canada, I've studied a lot of the organic farms in British Columbia and across Canada, and the average organic farm has 3, 4, 5, maybe 6% carbon content in their soils. 6% is about the highest you would see. Conventional farms here in Canada have perhaps 1 to 2% carbon levels, so organic farms have higher carbon levels in their soil, but Terra Preta are considerably higher than that. And I'll be coming back around to that in a minute as it relates to the climate. In any case, when we tested the Terra Preta that we created at the Sachamama Center, we found that it had good structure, it had good aeration, it had very good water retention, it had very high microbial activity because of the fermented microorganisms that we added to the soil that got all of those good mycorrhizal fungi into the soil. And it also had a pH of between 5.5 and 6, which compares to the natural oxasols that are more acidic and closer to a pH of about 4. So for those of you who ever garden or farm annuals, you'll know that a pH of 5.5 to 6 is a very good pH for a lot of plants that one would want to grow. So in any case, the Terra Preta that we were creating across the board had better nutrient levels, aeration, structure, etc. was superior soil in just about every way. Now I will go quickly through the steps of how we made Terra Preta, and I will get to the part where we make the biochar. So step 1 along our journey was to gather and weigh 300 kilos of cow manure. Steps 2 and 3 were to gather mainly carbon-rich materials from the on-site compost beds, which are on the right there. So obviously there's more than just carbon in there, but mainly we're adding C, or soil organic matter, into the mix here. A bit of other macronutrients as well. And then step 3 was to collect what's called bagazo, which is the residue that comes from sugarcane. The area around Lamas produces quite a lot of sugarcane, and as you can see from that big pile, there's a lot of carbon-rich residue that can be used as mulch. So you don't have to use bagazo, but it's important when you're making a sustainable soil to use what is local and abundantly available and also free. So these are steps 4 and 5. Step 4 was to gather sacha inchi nuts. In fact, the hulls or the husks or the shells of the nuts. Sacha inchi grow plentifully in Amazonia, and they are used as oil, cooking oil and such. But there are many of the shells laying around, and so we gathered a lot of them, and they were used to help aerate the Terra Preta. And step 5 is the gathering of coconut husks, which are also locally available and abundant. And we use these as the feedstock for the biochar. This is what the biochar was made out of. Before moving on with our steps of how to make Terra Preta, it's time to define biochar and pyrolysis, since they're important to the process. Pyrolysis is the heating of any kind of biomass, any plant really, at very high temperatures in an oxygen-starved environment. And it is through pyrolysis that one makes biochar. And essentially what you do is you cook a plant material at a very high temperature, and you cook everything out of it that is not carbon. You get rid of all the other components, all of the water. You cook all of that off at a very, very high temperature, cooking it in ovens at hundreds and hundreds of degrees. And what you're left with is an almost pure carbon mass, which can be used as a very stable soil amendment. So I'm often asked, what is the difference between biochar and charcoal? Well, they're fairly similar, but charcoal has a higher oil content because it is meant to be burned for cooking food and barbecues, etc. Whereas biochar has little to no oil in it and is not meant to be burned. It is meant to be placed into soil where it can remain in a stable form literally for thousands of years. So the ancient Terra Preta that has been discovered, going back 9,000 years, still retains its original biochar. It just remains there for, maybe not for forever, but for a very long time. So why is this important? Well, one, it's important because it is a carbon sink. You're locking carbon in as biochar, and it remains in a very stable form of carbon for thousands of years. It also, and more essentially for the soil, creates what is called habitat for beneficial microorganisms and fungi and bacteria, especially fungi. And habitat is a term that is used to describe biochar by soil scientists. A single gram of biochar, a very small piece of biochar, has up to 300 square meters of surface area on it. That is how porous the biochar is. That is to say, it is full of very small holes. And these small holes are, in a sense, little caves or crevices that harbor and protect microorganisms. And that is why it's called habitat. So the biochar is colonized by fungi and other microorganisms that use the biochar as habitat and are essential in the transfer of nutrients within Terra Preta. And this helps to explain why Terra Preta soils retain their fertility over time. So there's an obvious link here to climate as well. And many farmers, many organic farmers and permaculturalists use the term climate farming, which is farming with climate change in mind. And so one of the reasons that biochar is so important is because it enhances the carbon levels of your soil and locks up a lot of C in a solid form rather than in the form of carbon dioxide. Okay, so now that we understand what biochar is, we're back to our steps. Step 6 was to gather what are called chapaha fruits from local palms, and these were used to make the fire in the biochar oven. And step 7 is to actually pyrolyze, that is to say, cook into biochar the coconut husks that I showed you in a previous slide. This is the little biochar oven on the right that was made at the Sachamama Center, and several similar ovens have been made in the indigenous communities surrounding Lamas. I saw several of them. They all function on the same mechanics or based on the same model, and you can find models for these online if you're interested in making a biochar oven. But they essentially circulate the heat back around to the small area underneath the oven where the fire is burning to intensify the heat, and they also use a little motor that blows more air into the fire to heat it up. But they're very basic, simple earthen ovens. And in any case, this is what we used to make our biochar. So these are some photos. On the top left, you see us dousing the biochar with water because, of course, if you continue to cook any woody material, such as coconut husks or any carbon, it will eventually burn to ash. So you have to stop the process of heating by dousing it with water. On the top right, you see the biochar oven being loaded with the chapaha to make the fire underneath the actual oven itself. And the temperatures are quite high inside. The fire, I can't remember the exact temperature, but it's hundreds and hundreds of degrees, much hotter than your average fire. And it must be at very high temperatures to cook out of the coconut husks all of the material that is not the carbon. On the bottom left, you see a picture, a close-up photograph, microscopic photograph of a piece of biochar, and there you can see all of the little porous holes, all the little caverns in a piece of biochar that serve as habitat for microorganisms. And in the bottom right, you see some of the biochar, what it looks like when it's added to the Terra Preta. It's got that dark black complexion, which is mainly the reason why Terra Preta is called dark earth or black earth, is because of the biochar. So now we get to the fermented microorganism brew that we made, and these are steps 8 to 11. One of the essential aspects of Terra Preta is the presence of beneficial microorganisms and especially fungi in the soil. And so in effect what we're doing here is proliferating microorganisms through a process of fermentation. And the idea is to attempt to replicate ancient practices of fermentation, which we are pretty sure existed throughout Amazonia. So what we did was we essentially created our own fermented concoction using non-chlorinated rainwater. That's the first step, or step 8. Then we collected Microorganismos del Monte, which were essentially leaf litter that was collected from the forest or from the jungle that were covered in fungi and other microorganisms. That very distinctive white color on the underside of leaves that one finds that are semi-decomposed. We then collected rock dust from a local quarry, which is rich in a lot of micronutrients, which are also important for plants. And then we used rice bran and raw cane sugar to add to our fermentation. And then we fermented this brew both aerobically and anaerobically in a fairly complex process, which I won't be able to explain fully here, but there was later a second and a third fermentation, and this lasted for several weeks. If you want more information, you can go to the website of the Sachamama Center and get a better sense of what this fermented brew is all about. But essentially, if you were to, when you take the top off of it and smell it, it smells very similar to kombucha or to maybe a bit like yogurt, but I would say mainly more like kombucha or kefir or kefir. And I think there are a lot of the same bacterial strains are found in this brew, although I'm not quite certain. But in any case, we spent a couple of weeks making this fermented brew in an attempt to proliferate beneficial microorganisms. Finally, we mixed them all together. So we placed together the compost and the manure and the mulch and the sacha inchi nuts and all of it, and the biochar, as well as the liquid fermentation and all the other ingredients, to create this fertile, stable, nutrient-rich soil, which you then let sit for a little while before you place it into beds. Now, I've suggested in this lecture that Terra Preta can be used both to grow annuals or short-lived plants, as well as trees and other perennials that live for years and years. And I just want to confirm that at the Sachamama Center, Terra Preta is being used for both of these things. So it is a soil both for trees and also for other plants such as beans and corn and cilantro and many other things that are grown in the area. Tomatoes, peanuts, all sorts of plants grow well in Terra Preta. So the Terra Preta that we were making today was to be added to a new bed to grow annuals. So Terra Preta, modern Terra Preta, is being used not only at the Sachamama Center, but also in surrounding indigenous communities. And in the photograph here on the top left, you see some Terra Preta beds at a local middle school that were created by students as a kind of experimental plot. And this is indicative of some of the changes that are going on in Amazonia, where Terra Preta is being adopted by the locals, both the indigenous and the mestizos, as an alternative to Swidden agriculture. It's pretty well understood that deforestation is a big problem, and that building one's own fertile soils is the alternative. So you're beginning to see more and more gardens that look like this, although there's still a long way to go. So coming to the end here, just to confirm, what is the value of Terra Preta? Well, it's important to understand that the world loses 24 billion tons of topsoil every year. That's according to David Montgomery. And we continue to treat soil as a finite, non-renewable resource that is essentially mined and exhausted. So Terra Preta represents an alternative to that, a sustainable form of soil building. According to Uta Scherb, who's written a recent book on Terra Preta that's sold very widely, Terra Preta can be one of the main strategies for mitigating climate change. She writes, quote, "Climate gardeners using Terra Preta can reduce greenhouse effects on the Earth's atmosphere. If we, by means of climate farming, were to raise the humus content of soil by 10% within the next 50 years, the carbon dioxide concentrations in the atmosphere could potentially be reduced to pre-industrial levels." That is it's an amazing quote, and it's an amazing argument. It's very difficult to raise the humus content of soil all around the world by 10%, but it is a very simple, inexpensive, effective way of mitigating climate change, because building carbon back into our soils removes carbon dioxide from the atmosphere. Further, there is a new initiative called the 4x1000 initiative that was signed at the Paris Climate Accord in 2015 by several dozen countries that agreed to increase the soil organic matter in their agricultural soils as a means of mitigating anthropogenic climate change. So Terra Preta is part of the climate solution. If you want to read more about Terra Preta, there's many scholars working on it, including Johannes Lehmann, the soil scientist, Susanne Hecht, Frederic Apfel-Marglin, who runs the Sachamama Center, and then William Woods and William Denevan, who are anthropologists. One of the things they've found, by the way, is that Terra Preta is able to reproduce itself. That is to say, it will colonize the soils around it, and it will actually spread over time. And there's still a lot of debate as to how and why this is, but the main theory is that it is the fungi and the beneficial microorganisms that colonize surrounding soils and transform them. So it is pretty magical stuff, for sure. So we now come to the final slide, which is asking the question, what is the value of biochar and Terra Preta in the global north, or at least outside of Peru? Well, for those of you who are listening today who live in the tropics or in the subtropics, places such as Australia or other parts of South America or Africa or parts of Asia, I think that there is a real argument to be made that the use of biochar and Terra Preta, a locally adapted Terra Preta, would make a lot of sense for sustainable agriculture or for sustainable permaculture. But it's also being used in the global north. Biochar is now used in Switzerland, Austria, Germany. It's being introduced into Canada and the United States. Biochar is for sale at some agricultural supply stores right here in my own town. I know people are buying it. There are a few farmers I know who have built their own biochar ovens, and they are pyrolyzing their own biochar. So it is beginning to be used here and there. It's been studied at the University of British Columbia that found that it increased the density of germination, increased germination rates amongst certain plants. But there's still a lot of research to be done about understanding what the value of Terra Preta and or biochar is in northern soils. Because of course, we don't have oxisols here. We have very different kinds of soils in the north, and it's not clear how important Terra Preta would be for our agricultural scene. That said, there is a lot of argument to be made that biochar could become an important soil amendment in northern soils. It has very high carbon levels, and it is therefore a useful technique for transitioning a farm from conventional to organic production. A lot of conventional farmers have very low carbon levels and they want higher carbon levels. So the use of biochar is a way to very quickly add stable C into the soil. But even for organic farmers and permaculturalists, it could be a very effective way of adding stable carbon into the soil profile. As I mentioned, there is interest among many local farmers where I live and farmers across North America and Europe. There is a new magazine on biochar, and there is an online research portal, which I've included a link to here for those who are interested in learning more about biochar. So thanks very much for listening to this lecture, and I hope you've learned something about biochar and Terra Preta, and maybe have some inspiration as to how it could improve permaculture in other parts of the world. Thanks very much.